times negative t to the 2 halves plus, and I'm just going to put that in front of it, so that would be 4t to the 1/2 dt. Now, why am I writing this part out? Because this is where the screw-ups are going to happen, right here. What's 1/2? First of all, you got to, what's t times negative t? That's a negative t, right? But what happens to the exponents? What happens?
Add them together.
You add them together, and what do you get?
3 halves.
3 halves. So that would be negative t. I'm running out of room. Bring it down a little bit, I know. I know y'all are impressed. All right, 0 to 4 of negative t to the 3 halves plus 4t to the 1/2 dt. And now you're ready to do the antiderivative. So that's going to be negative t to the 3 halves plus 2 halves over 3 halves plus 2 halves plus 4t to the 1/2 plus 2 halves over 1/2 plus 2 halves. Evaluated at 0 and 4. And 3 plus 2 is 5, so that's negative t to the 5 halves over 5 halves plus 4t to the 3 halves over 3 halves. And then that's going to be evaluated at 0 and 4. 2/5 t to the 5 halves plus 2/3 t to the 3 halves. Say again.
Four dispute in that.
Did I mess up something?
Yeah,
If
four
it's
dispute.
4t, it'll be
Oh yeah, I just ignored it. That's good. Good, Hubert. Plus 2/3 be 8/3. Thank you. All right, I'm going to erase that side of the board and rewrite this over here. So make sure you got that down. Now, a lot of you may see already, how do I teach? I teach very methodical, and I teach every what?
Step.
Why?
Because
Because if you already knew the material, you wouldn't be in here, right? All right, now I'm not saying that about the review. I'm saying, that's the way I teach, because I'm going to get into the sections that you haven't been in, and that's the way I teach. Okay? So if you don't like it, I hate it. So, negative 2/5. And I'm going to go ahead and change this. Exponent over what? Index, so that's the square root of t to the 5th. Plus 8/3. And that is exponent over index of the square root of t cubed. Evaluated at 0 and 4. Now, what does the 0 do? Takes out the second term, right? So we don't have to worry about the 0. So all we got to worry about is the 4. Negative 2 square root of 4 to the 5th plus 8/3 square root of 4 cubed. Now, what is the square root of 4? 2. So 2 to the 5th is 32, right? So negative 2, that'd be 32. Plus, what's 2 to the 3rd? 8, Hubert. That's right, class. So check my math.
It's not 2, 2, is it?
Say again.
Oh, you, never mind, sorry.
Square root of 4 is what? 2. 2 to the third is 8. Square root of 4 is 2. 2 to the fifth is 32, I think.
Yeah, I didn't see that you were taking the square root first.
Or 4 to the third is what? 64. The square root of 64 is 8. 4 to the fifth, that's a BA number. I have no idea. So you can do it in your head if you're Rain Man, but I can't. So 32 times 2 is negative 64 fifths. Plus 64 thirds. And you got to have a common denominator of 15, I guess. And that's negative and plus. And 3 times 64 is 196. Help me out. 192. Is that right? And 5 times 64 is 320. Is that right?
Okay.
Negative 208.
128.
128. I'm sorry. So that comes out to be 128 over 15. Thank you. So that problem may have looked like it was basic, but it had a little bit of algebra in it, didn't it? Because calculus, it wasn't very hard. Calculus was real easy. Question, right, complaint. What's the derivative of sine? And what's the antiderivative of the sine?
Negative.
There you go. You got to remember those because those are a pain. You got to memorize them.
What about the secant, cosecant thing?
Yeah, just memorize them.
Or no, which is it where it's like 1 over the square root of?
Well, I'll show it to you. I've got them already pulled up. There you go. Talking about the antiderivative right there.
Yeah, 1 over the square root of 1 minus x squared.
And that's the arc sine, and that's what we're going to get into in 5.6. That's what we start with the arc sines and the hyperbolic. But I don't spend a lot of time on the hyperbolic because you don't ever see it. You do see the arc sine in Calc 3 though, and I cover it more than I cover the hyperbolic. All right. Let's see what else is in that chapter of review, because that's the second. That is the chapter review. The second part is chapter, whatever chapter this is, 5. I can't remember what we were in. Yeah, 5. And we just did around 5.3 where we are right now. Indefinite integrals. That's not a big deal. If you can do an antiderivative, you can do an infinite or a definite. I mean, it's not that difficult. They make it into something very complicated, but it's not. I mean, you could basically show all of what you need to know in one section, and they got it expanded out into 3 or 4 sections. So don't let it get you intimidated. But the only difference between a definite and an indefinite integral is what?
Indefinite, or a definite one has parameters.
It has parameters. It has A and B in it. That's it. Question. Right. Complaint. And they show you how you can subtract rate of change. Not a big deal there. I was going to look at a couple of examples here, but like I say, it's kind of redundant. Like this one right here. That one looks like it's complicated. Let me blow it up a little bit. I'm trying to look at both things at one time. See that problem right there? just break it up into 4 little problems. The antiderivative of x to the 4th minus the antiderivative, or 1/2 times the antiderivative of x cubed, plus 1/4 times the antiderivative of x, minus 2 antiderivative of dx. And the only difference is you don't have numbers here. But they did that back in 5.1 and 5.1 they showed you how to take the antiderivative, and now they're showing it to you again. So, I don't know. Maybe that's why I'm not writing books. I probably make too many mistakes. Alright, so that one is pretty self-explanatory. What about this one?
Boil
Exactly. That's another one. That number 2 is another one that people stare at. People don't stare at the first one because they know from Calculus 1 that if you have a product of terms, you just break it up. But the problem is when you have like number 9 or that problem we did a while ago where you had to distribute, that's where people have the Patrick Starfish moments and stare at it and go, I don't know what to do. Just rely on your algebra and get it into the one before it, number 7. Get it into that type form by using the FOIL method. Pronounce it however you like. 11. Again, it's a same thing, but what do you do with 11? What can you do with 11? 11 is a good test question also.
Break it up into 2 fractions.
You could do that.
Could you divide out x?
Hmm?
No, I don't think you could take x out of the square root.
I'm asking y'all. That's not the easiest thing to do. That's okay. And
Multiply everything.
breaking it up, huh?
Multiply everything by x.
X to the what?
First thing.
Not the first power. When you bring it up, what happens? Negative. So you might want to do number 11. Let's do that one because that's a test question. I'll put one like that on the test. And yes, we could break it up into x cubed over, but what are you going to end up doing with that? You're going to bring the x up anyway. So you can do it either way. You see why people have a hard time with calculus? Because they always have to fall back on what? The algebra. You cannot have calculus without algebra. Ow, God, I just shot myself. That hurt. Antiderivative of x cubed minus 2 square root of x over x dx. Yeah, that one is one that you'd stare at a little bit. And I'm going to rewrite it. X cubed minus what?
X.
to the 1/2.
To the 1/2 over x dx. Now, yes, you could do x cubed over x minus 2 antiderivative of x to the 1/2 over x dx. You could do that, and there's nothing wrong with that, but eventually you're going to do what with that x? You're going to bring it up, or you're going to use the quotient rule of algebra, either one. So I'm not going to do it that way, but you can do it that way. I'm going to bring this x up. So antiderivative of x to the -1 times x to the third minus 2x to the 1/2 dx. So what is 3 plus a -1 or -1 plus 3?
2.
Thank you. Minus 2. And what's -1 or -2/2 plus 1/2? -1/2, Hubert. Thank you, class. Huh? Y'all right up there, ball of fire, I tell you what. All right, so now we're gonna take the derivative, and that antiderivative, and that'll be x to the third over 3, no problem, minus 2, and then let's take the antiderivative of x to the -1/2, so that's gonna be x to the -1/2 plus 2/2 over -1/2 plus 2/2. And then that's going to give us x cubed over 3 minus 2. And then we're going to have -1/2 plus 2/2 is 1/2 over -1/2 plus 2/2 is 1/2. Dang old, multiply by the reciprocal, dang old 4. X to the third over 3 minus 4, x to the 1/2, dang old plus 2. And if you wanted to make it a little bit prettier, you could have 1/3 x to the third minus 4, x to the 1/2 plus c. Several different ways you could write it. You feel good? Everybody got the cobwebs knocked loose a little bit?
Yes, sir.
That's the main thing we're doing right now this first week. Unless y'all want to just jump on into it, I mean, we'll be glad to. That's a good test question. You're going to get several of these and these. And that problem I showed you a while ago where we distributed the square root of x, that's another one. Indefinite. Where, somebody look at the syllabus. Where is the first two sections? I thought it was 5.6 and 5.7, but what is it? Somebody look in the syllabus right quick. It must be 6, chapter 6.6 and 6.7. It's the hyperbolic and the arc sine, or the arc trigonometric functions. I thought there was a 5.6 and a 5.7. That must be in the old book that we used to use. Okay, y'all find it in the next 15 minutes, you know. It's one of those difficult things that y'all have to find a handout. Right? Well, here's another one, 25. That's a good test question. Why is that one a good test question? Because we use the old dang old FOIL method. Let's try that one out. 25. It's a definite. So you might have to do a little bit of math. Darn it, what happened to it? What number did I say?
25.
Thank you. There it is. And then we'll try to do 27.
Syllabus it starts at 6.1.
I was in the old, I was thinking the old syllabus. What is 6.1? I mean, what's the title of it?
Areas between curves.
Oh, well, that's good. That's fun. Did y'all do any of that in Calc 1?
Area under the curve or between?
Huh?
Area between the curve?
Mm-hmm.
I don't think so.
Well, then that means you're gonna fail. I'm sorry. There's always the ditch.
It is what it is.
Live in a ditch. 25.
Just a question, when there is a definite integral, you don't add the plus c at the end, do you? It's just,
On a definite integral, no, because you're actually looking for the area.
yeah.
No, you don't put the C. The only time you put a C is when it's indefinite. All right, so we're going to use the FOIL method, pronounce it however you'd like, and that's going to be 8x to the third plus 2x minus 12x squared minus 12x squared plus 2x minus what? 3 dx. Y'all check my algebra. And that's going to give us 8x to the fourth over 4 minus 12x cubed over 3 plus 2x squared over 2 minus 3x evaluated at 0 and 2. Now, do you also notice something else I don't do when I'm explaining something to y'all?
You don't just go ahead and do the rest.
I don't skip steps. Again, my job is to teach the material, not to assume you already know it. So that comes out to 2x to the fourth minus 4x cubed plus x squared minus 3x, and y'all check it against what y'all have, and that should be what you come out with. Now, luckily, they give us a 0, so we don't have to do 0, because 0 takes out everything. So we just have to plug in 2. 2 to the fourth minus 4, 2 cubed plus 2 squared minus 3 times 2. And 2 to the 4th is 16, so that's 32. (32) minus 32. 8 times 4 is 32, right? Plus 4 minus 6. Dang, 32, 0, 4 minus 6 is negative 2. What'd y'all get?
Negative.
It's a miracle. We feel good about ourselves. Now again, how much of that problem is calculus? 10%? Maybe 15%? Rest of it's algebra and math. Once you break calculus down to its components, you start to see that it's not that what?
Difficult.
It's not. I'm just setting y'all up for the slaughter is what I'm doing. Once you get your confidence built up, and then I just tear it out from under you.
Chapter 6. Like a ton
Say
of
again?
bricks.
Huh?
So this chapter 6 could hit us like a ton of bricks.
Yeah. And you know, you lose your confidence, and then pretty much drop, and then I don't have to teach no more.
Are you teaching the summer class at all?
No, they usually let Dr. Anser teach the Calc III and the DPQ.
You should do the Calc 3 summer class.
I would love to,
I would take it.
so, but let's do this one. 27.
1, 2, 3.
27. So 0 to pi, 5e to the x plus 3 sine of x dx. Now, is this a problem that is easily, does it easily intimidate students? Yes, why? Because it looks complicated. That's why. But is it complicated? No, because the antiderivative of e to the x is what?
E to the x.
So that's not difficult. So if you ever get confused in calculus or anytime in math, you go out to the real world, get confused, what do? You break the problem down to its what? Parts, to its base. So antiderivative, 5 out front, 0 pi of e to the x dx plus 3 antiderivative of the sine of x dx. Well, we just said that the antiderivative of e to the x is what?
E to the x.
So that's going to be 5 e to the x. And I'm going to put the pi and 0 over yonder, so don't worry about it. Plus 3 times the what? The antiderivative of sine is the negative cosine, evaluated at 0 and pi. So your final function, 5e to the x minus 3 cosine of x, evaluated at 0 and pi. And you knock yourself out on a calculator. I'll do the 0 for you. No, 0 is not going to give you. Cosine of 0 is 1. So it's not going to give you 0. It's going to give you 3. So y'all crank that out. I'm not going to spend a lot of time on that. Okay? But the whole point of this problem, showing you this problem, is to show you that, just like in the real world, when you're given a problem, what do? Quit or break it down? You break it down. That's the whole purpose for 15 years of math if you're going to be an engineer. I don't want to cross a bridge with somebody that's had underwater firefighting math. Okay? So they don't know how to solve problems. They don't know how to break a problem down to its parts. You're gonna fall in the ocean and drown. Okay, what about 29? What's the first step? Change to what? I didn't hear you. All I heard was,
And you did the 1/2 in the bottom and bring it up.
bring it up. Distribute. What about this one? What's the first step?
Distribute.
The first step is to change what? Change the radicals, then distribute. How about this one? Do we have to do anything? No, just break it up. You have to rewrite this. Try 32. We'll do 32. Make sure your calculator's in radians. Did y'all get something different or what? Well, that's interesting. I just lost my stylus. Okay, now where in the heck did it go? There it is. I don't have any fingernails. You can't pick up anything without fingernails. All right. I done forgot which one we're doing, but 32? 32 says the antiderivative from 1 to 4 of square root of y minus y over y squared. Now the reason I like to do this problem, again, is this shows you how you can take a problem that looks like a cluster and do what? What can you do to it? Break it down and simplify it into something that you understand. Or you could just what?
Try and
Quit.
class.
Huh?
So try and leave class.
Yeah, and quit. Throw your pencil down.